Welcome to this whirlwind tour of free body diagrams. Let's learn physics. Remember that a free body diagram shows one object with only the forces acting on that object, and the point of view does matter. The most traditional and most common free body diagram point of view is the side view. If you need the normal force, the weight, the friction force, that's a good view. Another option is a top view. If you're not interested in the weight or the normal force, you can make the diagram easier by using a top view. A front view or a back view, both of those are good for turning objects because all you need is the normal force, the weight, and the force toward the center of the circle. Now on to our no number examples. We'll start off with a ball just sitting on the floor. The side view shows the obviously balanced normal force and weight up and down. The top view has the weight into the page, the normal force out of the page, so you don't see either of them. Next, ball rolling down the hall at a constant velocity. If you haven't figured it out yet, you should know this, that the constant velocity and the zero velocity are equivalent situations, and the free body diagrams will be the same. Next, an accelerating car speeds up in the forward direction. The up normal force and the down weight would balance each other, but there should be a larger forward force than backward force, assuming that there is some friction. Here's the top view. You don't see the weight and the normal force, and you can see the advantage of it. It's a lot cleaner, just the forward and the backward if there's friction. Now a rolling car stops. Side view looks like that, assuming that there is no forward force. It's all backward. Top view, again, a lot cleaner, just a backward force acting on the object. Now a quick inclined plane problem. Sitting at rest, all you see is the weight, the normal force, and the friction force, all balanced, holding everything in position. Same inclined plane, cart rolls down. Assuming no friction, you just have the weight force and the normal force. A tennis ball in free fall. Assuming no air friction, the weight is the one force. A coffee filter at terminal velocity has the weight down, balanced by the air friction force up. Now for the monster in the elevator problems. This one, sitting at rest, normal force and weight are the same size. Accelerating upward, the normal force is greater than the weight to cause that acceleration by an upward net force. And remember that the normal force is that force that is read by the scale between the person's feet and the floor. Now accelerating downward, you have a weight force that is greater than the normal force. And now, helicopters. This is the free body diagram of a helicopter either hovering or moving up or down at a constant velocity. I use the term thrust for the force of the air on the blades. Next, helicopter moving down, slowing down and stopping. The up force has to be bigger than the down force because the acceleration is up. Helicopter and elevator problems are very similar. Now here's a helicopter moving up and slowing down. Velocity's up, acceleration's down, therefore net force must be down, therefore the weight has to be bigger than the thrust. And now the top view of a car turning the corner without changing speed. Speed doesn't change, but the velocity does because there is an acceleration to the left, perpendicular to the motion, and at any point that net force would be toward the center of the curve. A view from the back of that car shows the balanced up and down forces and the friction force that causes the turn. Here's a crazy one. Car turns left and speeds up. The acceleration and net force are both forward and left. So you have the surface friction force causing the turn, and you have the bigger forward force than air friction force to cause the speeding up. Yeah, that's a good one. You've got the speeding up acceleration, which is the tangential acceleration, and the turning acceleration, which is the centripetal acceleration, which gives you the net acceleration shown, same direction as the net force. We spend a whole lot more time now in physics class dealing with free body diagrams because honestly, they really change the way we see the world. My students aren't good at seeing the world. Y para hacer la hamburguesa completa hay que poner la hamburguesa, el queso y un huevo frito y jamón. Rico es.